all morning long, and for the rest of the week, you're going to hear about test beds, and you have heard about test beds. So hopefully you have visited either the Industrial Internet Consortium booth, just over here, where we have, I think it's 16 test beds that you can see live, running to see. And then behind the IIC booth is the Platform Industrie 4.0 booth, where you, again, can hear about live, real test beds. But what we decided to do was talk specifically about real test beds here. So IoT is not a particularly new idea. What has caused it to be so important so quickly is the focus of ubiquitous communications, low-cost compute power, low-cost storage, and low-cost sensors and actuators. The IoT pattern is a very simple one. Collect information from thousands, potentially millions of sensors, potentially worldwide. Do real-time predictive analytics on that information as it comes from the sensors. And then either deliver it as decision support to decision makers or have direct impact on actuators in the real world. So we put together a panel. I'm going to sit too. We put together a panel of 4 of our most active participants in the IIC Testbed, in the Testbed program, in which there are now 26 or 27 running testbeds. And we're just going to have an interesting conversation about not how the testbeds are approved, but what do they prove? What do we learn from these testbeds? What are the outcomes of the testbed program? So from left to right, we have Todd Walter from National Instruments. If those of you who were here last year might remember, you were on the testbed panel last year as well. Next, moving left to right again, Stan Schneider is the CEO of Real-Time Innovations, RTI, which has been heavily involved in our testbed program as well. And Stan is also a member of our steering committee, representing our small industry members. Next is me. I'm Richard Soley. I'm the chairman and CEO of the Object Management Group and also the executive director of the Industrial Internet Consortium. Then we have Kim Watson. Kim is deputy head of the ILT department, but we don't know what ILT stands for.
For information management and production control.
Information management and production control. I think that's what the L stands for, apparently.
In German.
Yeah, okay, in German. I thought it was Spanish, but with Fraunhofer IOSB. And last but not least, Jayraj Nair, who's the head of Internet of Things at Wipro Technologies, a worldwide systems integrator. So what I'm going to do is ask each of them to start with a small story. Tell me why you ended up here on this panel, besides the fact that I asked nicely. And then tell me something interesting that you've learned from the testbed program so far. And don't focus just on the technology, because it's not just about technology. It's also about, did you learn about how to partner? Did you learn about how to train, how to hire? Anything that's important to making decisions about using the Internet of Things in any vertical market. So a lot of the talks so far have been about manufacturing and production. But the Internet of Things is causing major disruptions in healthcare. It's causing major disruptions in energy distribution and transmission. It's causing major disruptions in smart cities. It's all sorts of things. So we'll just move left to right. And Todd, if you could start.
Sure. Well, so everyone, thank you for coming today, listening to us talk. National Instruments is involved in a number of the IIC testbeds. I personally spend time on one of the testbeds around time-sensitive networking. That's some new capabilities that have been introduced into the Ethernet standard that allow a convergence of control systems with IT systems. And in the IIC, we have a testbed around time-sensitive networks for flexible manufacturing. We started this testbed about 1.5 years ago, and we've now ramped up to where there's 20 different organizations that are now participating in this testbed, and it has 2 different instances, one in North America and one here in Germany. Actually, both of those are here at the show. One is in the IIC booth, one is in the OPC booth. I guess I'd say of the things that we've learned going through, I've spent time working on the standards bodies in IEEE. I've spent time in a group doing conformance, interoperability, and AVNU. Spent time in a group in OPC looking at how we kind of keep building on top of this. And the IIC testbed, what's been the most interesting there, I think, is despite the same people participating in many different groups, when we get together in these test beds and really try to put the pieces together, that's where you uncover all of the differing assumptions. And that's where you uncover all of the things that if we didn't have test beds, our customers would be finding out in the marketplace. And so I think it's that even when everyone builds on the same standards and engages in all the same conversations, the end results end up not quite being the same. And these test beds, I think, have proven to be a very effective place at finding out those differences.
Thanks, Todd. Stan, I know you've got stories. By the way, you should be thinking of questions. What should they be answering? What do you need to hear about how the test beds work and how they impact your industry?
Hi, I'm Stan Schneider. I'm probably here because I, amongst other things, chair the subcommittee on approving test beds and test bed strategy at the IIC. Maybe I will tell you a story about how I ended up in that position there, because I joined the steering committee, and when I did that, RTI is a small company. We're actually involved in 15 different consortia, and we jumped into the IIC for a couple of reasons. One, it's a good strategic match to what we do, but also because it was the first consortia that I'd seen at the time that actually had this concept of let's build test beds and really do it. And what's really unique about that is they started with the idea of test beds. And I've been involved with other consortia, for instance, in the Navy, where they start with, well, let's build an architecture, and then we'll put together some standard proposals that fit that architecture, and then we'll put together test beds to test the standards to build the architecture, and then we'll put together products that are compliant with the standards, and it takes 20 years. And the ISC has this idea of doing all these things in parallel, and it's messy. I mean, the test beds aren't compliant with the architectures aren't compliant with the standards, but we're iterating about once every 3 years or so, and we're actually going through an iteration now, and I think it's working out very nicely in that we actually are now making some serious impacts on standards like TSN, which is not a complete standard. It's a standard information. I'm very involved with a microgrid test bed, and we actually have a standard we just approved called OpenFMB in North America that's for building microgrids in the power grid, and it's really interesting to be part of that. But the reason I'm doing this subcommittee is because it really hit a nerve in the industry. The industrial Internet of Things is a huge opportunity. It's out there, but without some way to actually validate what's going on and test things, there was no meat behind all these things people were saying. And because of that, it took off to the point where the steering committee meetings were 100% dominated by evaluating test beds. And that, got to be sort of annoying. No offense to the chairman. And we decided that we should create a subcommittee to go off and do that, and that's how I got involved in that. So it's really an interesting and amazing world out there. The ISC is still pretty much unique. Everybody says they have test beds now, but the ISC has by far the most broad test beds. There's technologies like TSN. There's a security test bed. We run 5 different test beds: microgrid, transportation, connected healthcare. We're actually part of the security test bed, one called Edge Intelligence, and but they go on from there. There's airline baggage management, smart crop management, and on and on and on across a big chunk anyway of the spectrum of the industrial Internet of Things opportunity, and it's a pretty exciting world.
You sound excited.
I'm excited.
Yeah. Kim, please.
Right. We at Fraunhofer lead the Smart Factory Web Testbed together with our partners in Korea, Katie, the Korean Electronics Technology Institute. This testbed is all about interconnecting factories to achieve adaptive, order-driven production. There are 2 model factories in Korea and 2 here in Germany. The main motivation for us and the main benefit from being an ISC testbed, I think, is the interaction with many different companies, users as well as technology providers, the guidance provided by the IAC Steering Committee to sharpen our statements and our presentations has been immensely valuable and has led to lots of follow-on activities. And by the way, our two model factories here in Germany are also members of the Labs Network for Industrie 4.0, and so via this route we hope to contribute to the harmonization between IIC and Industry 4.0.
And last but not least, Jayraj.
Thank you. Good afternoon. Thank you for being here. My name is Jayraj Nair, and I head the IoT business for an Indian systems integrator that has a global footprint called Wipro Technologies. From a testbed standpoint, we are part of the deep learning testbed, but overall, if I were to just focus on what did we learn by doing these testbeds, I think over the last 2 years, the number one learning for us has been it is an ecosystem play. What that means is at the edge tier, at the platform tier, and at the enterprise tier, we got to be working with multitudes of partners, collaborating, and building solutions together. That is one of the most important learning, which is you cannot simply stand up a vertically integrated stack. You got to work with partners. The other learning, which is equally important, is earlier on, if you look at the use cases, we were very excited. We would connect. We are all engineers, so typically data acquisition at the edge, send it upstream, do some analysis. It was all about connecting and staying connected. Over time, we realized that we have to start looking at people, processes, and technology at the same time. So digital transformations are not just technology transformations. They have a lot to do with people transformation. How do you hire people? What type of processes change? Because as an example of predictive maintenance, if a ticket gets issued by a computer system that has analyzed a lot of ongoing event streams, that ticket has to actually trigger a technician to go out and service that part or that product. Now, that level of integration on how that trigger actually enables a worker in the plant or in the field, those kinds of learnings are very critical. We figured out it's not just about Internet of Things, it's about Internet of Experiences. Real customer experience, real worker experiences in this connected world.
So everybody talks about how valuable it is and how you're learning all sorts of interesting things through these test beds. Are you willing to share them? Anybody want to talk about that? What if they wanted to hear them? Would you share that learning, or are you keeping it to yourself? Is it part of the way that your company learns about implementing IoT? Nobody wants to answer that one.
So we're happy to share everything we do. We're a very open company. So we're learning a lot from the test beds. Actually, I want to pick up a little bit on the ecosystem play. Jayraj talked about it. It's absolutely an ecosystem play. When we joined the IIC, I knew what National Instruments was, but I certainly wouldn't call them a close partner. And now they're one of our closest partners. I'm actually on stage in NI Week. I don't know if you knew that, in the opening keynote to talk about what RTI is doing with one of our customers, Hyperloop 1. But it really has allowed us to build deep partnerships with many other companies that we wouldn't have had access to. As far as the test beds, and actually I think that is a key learning, is how you can work with other technologies to build something that doesn't exist today. Another thing we've learned is really how to take the results of a test bed and turn it into a standard that people can pick up and use, which you can't just write a standard without a test, and you can't do a test without a standard. As you know, the standards industry, there's a very delicate time frame between when you have enough knowledge to know what it is to write a standard, and when you're too far and everybody's already calcified and decide what they're going to do, and they'll never be able to get together. And I think the biggest learning I've had as a test bed is a great way to really push that forward a little bit and accelerate the standards to market.
So that's the first time somebody mentioned developing standards from what you learn from test beds, which is actually one of the major reasons why we do test beds. Is anybody else seeing that result?
Yes, I can underline that twice, Stan. The standard's absolutely essential to have sustainable IoT systems, especially in industrial applications. And there are a number of standards already being used in the test beds. I think more will come. And because of this pre-competitive environment here, it's in fact, as just mentioned, an ideal situation to exchange ideas on what should be in the standard.
Don't we already have enough standards for IoT? All the MTM solutions and middleware. That's really all we need, right? Is how to get bits from here to there. Yes, I'm being sarcastic, but somebody ought to answer.
I'll answer that one if no one else.
Well, sure, it is getting the bits from here to there. I think the argument is that, no, we don't have the right infrastructure and the right standards for that. I'll comment specifically on the TSN infrastructure. There's been a lot of work over the last about 7 years in IEEE in building a set of standards for how we can deterministically get bits between control devices on a converged network cable. And you were asking about some of the learnings. What we see is that the standards that are there are very, very good. The IEEE does a very good job building those standards. But what we discover are the gaps between those standards and the other pieces that need to get filled in. Now, often that's around gaps for system level configuration. We want a consistent way that all of the network devices, whether they're from Cisco or from Belden or from TT-Tech or someone's built them into a device, we need to make sure that all of that network configuration happens in a consistent, scalable way. Otherwise, getting the bits from here to there is the least of your worries. You're spending all your time trying to do network management. I think that's an example of the kinds of pieces we've found that the base standards are good. And what we're really doing is identifying the kind of ties between those that are needed. And a testbed's a place that we can do that in a very real-world scenario. It's not one vendor making the decisions because naturally you have blind spots to what's needed.
So is nobody going to mention my personal hobby horse of semantics?
I was going to do that.
Okay, good.
Yes, because exchanging the bits and the bytes is pretty easy at the first few levels, and the next challenge beyond the connectivity framework that's just been released, of course, is to tackle the semantic interoperability and have come up with good standards for semantics. And it's a real challenge, of course, because there are some very complex issues about how to describe information models and concepts that vary from domain to domain and from culture to culture.
So as you know, actually, because Fraunhofer also participates in the object management group, that is the primary focus of the OMG, is semantic standards. But there must be some other reason to get involved in all these test beds. I mean, 27 of them now, 26, 27, something?
Right. I think you talked about standards. Beyond standards, I think the interoperability, the one reason we are sitting here, for example, with Industrie 4.0, if you look at the mapping of the IIC reference architecture and the Industrie 4.0 RAMI architecture, that interop conversations are happening today. The idea is that if, for example, for our global clients, they are everywhere. So when we build a solution, it's not unique to the United States or unique to Germany. These solutions have to be deployed globally. So the more interoperability conversations and partnerships happen like this, it only helps us build these solutions. Let me get a little bit more specific in terms of cyber physical systems. How do you create a model? You mentioned the semantics involved. How do you create a digital model of a physical asset? The definition of those in the Industrie 4.0 construct would be within administration shell in RAMI. It could be within a digital twin concept within IIRA. So literally across all of these different frameworks that are there, interop becomes a very critical point.
I think you're talking about RAMI 4.0.
Yes,
right?
RAMI 4.0.
I'd really love to see RAMI 3.0 anyway.
No, I just mentioned 4.0.
The first one was 4.0. I'm sorry, Stan, you're trying to
So I'm actually happy with the characterization of the industrial Internet of Things as getting bits from here to there. But you got to know what bits, you got to know which here's and which there's, and more importantly, or at least importantly, when you're going to get them from here to there. And that's a real trick. I read a paper, I think it was Harvard Business Review a while back, so there's really only 3 things companies can do. You can make things, you can move things, you can store things. And with information came along, and you can make information, you can store information, you can move information. It's really the fundamental values of an industry. That's what it can be and is.
What do lawyers do?
What?
What do lawyers do? I'm just being nasty. It's okay.
You know, that's not a fundamental industry, frankly. lawyers are the only industry that can create their own demand. So think about that for a while. But I think, you know, the real trick is how you make all of that work, and interoperability. One of the things I've learned from Testbeds partially is I don't like the word interoperability anymore unless you put the word between after it. Interoperability without the word between is meaningless. Absolutely meaningless. Interoperability between vendors is meaningful. Interoperability between devices is meaningful. Interoperability between industries is meaningful, although not as obvious what you're going to do with it. But interoperability between, you know, connectivity frameworks is very meaningful. But you have to really think about that in a clear form to make that happen. So,
well, let me move in a slightly different direction. All the people that are sitting here are now fascinated with this testbed idea and would like to join Testbeds or start their own Testbeds. What do they have to do? How do they get involved in an existing testbed? How do they create their own? We might even start with you, since you run the Testbed subcommittee.
Okay, so I mean, getting involved in an existing testbed sort of depends on what you do. You're going to have to go and essentially talk to the leads of the testbed and sell your technology or service, whatever, as something valuable to the testbed, and then you can get involved with it. Because the testbeds are already, most of them are up and running and pretty deeply into their technology. There's lots of opportunities to do that, especially at, you know, the right time frames, intervals, that's fine. Creating a new testbed, while it's not a simple process, is actually very easy to do. You have to join the IIC, we'll start with that, or at least know some members that join the IIC. You have to go and get a partnership together. There are virtually no testbeds run by a single company. I don't think there are any.
I think there are none.
And you know, you have to come up with a concept you're going to test. You have to write a proposal. You have to put together a presentation, and then there's a whole process you go through where you get, you know, the testbed working group has to. You really want me to go through all this? Has to vote on
not
it,
the
and then
detail.
it goes to the steering committee, subcommittee, my committee, and then it gets voted on the steering committee.
That sounds bureaucratic.
It is, but
I'm
it's also very.
I'm not so much talking about the physical process, but how do you find, if you're a technology vendor, how do you find the right use case? And if you're a user, if you're a mining company or a banking company or a healthcare company, how do you find the right technology stack?
So, the use case is the hard part. I would suggest if you are a technology vendor, look to your customers and what they're trying to struggle with and what they need to, what you know. I think strategy for especially a small company is actually very clear. There's good strategy and bad strategy. There's like the book called that, if you want a recommendation. But a good strategy is what's key, you know, what are my goals? What's blocking me from those goals? And what's my strategy? How am I going to get rid of that blocker? And the testbed should be something getting rid of that blocker. So your goal might be to, you know, our goal for the microgrids is to change the way the grid works so we can actually get renewable energy more easily involved. That was driven by one of our customers, Duke Energy, which isn't even a member of the IIC and really isn't even that involved in the testbed, but was very adamant about they need a new architecture to do that. And then we went out and said, well, what's stopping us from doing that? Well, we don't have good, cheap hardware, not cheap, inexpensive hardware. Can we get together with a hardware vendor who's not really in that industry and really make it work? That we don't have good connectivity and connections. Well, we get together with Cisco, who actually does have a power system thing, but isn't in this particular part of the market, and get together with other utilities and put together a plan where we can actually create a significant pilot and testbed that the industry is going to listen to. I wouldn't build a testbed the industry's not going to listen to. You'll never get it approved.
Anybody have something to add there?
Just to supplement what Stan just said, I think the business outcome is the key. If you have a set of use cases for which you're trying to put a solution together with multiple partners, if you get a couple of customers involved, for example, if it's an airport waste management system within the airport or on-time departure use cases, if you have use cases like that, it'd be good to get 2 or 3 airports involved in the testbed. So it's not just about functional validation of the use case. It's also about the scale aspects. It's also about the value business impact standpoint. So I think if you focus on how to get real learnings out of a test bed, please do involve the end users of that test bed.
And I'll make one more comment. If there are companies, if you guys are out here looking to join Testbeds, you can go to the IIC webpage. The Testbeds are listed there. I'll comment on the ones that NI hosts. So we, this year, opened up a new facility explicitly to host 3 different Testbeds, one around condition monitoring, one around microgrid, and one around time-sensitive networking. And for all 3 of those, part of our background on why we built the laboratory for those was because we wanted it to be open to other partners coming in. These Testbeds both prove out how can the pieces go together to solve an application, and that's almost by definition in the industrial internet, that's going to involve multiple different companies. And so you have to have a place that we can all get together and collaborate. And then second off, once we have that built, we want to be able to go through and explain that to the marketplace and to our customers. And I think it's one of these pieces that's viewed a lot of different competitors work together on these test beds. And we welcome that. So, you know, I'll build on, sometimes it's a timing instance. It may be difficult to join right now because of where a particular testbed phase is in, but we try to make sure we have routine phases opening up to allow additional companies to come in. And just because you see a competitive name that's in one of the testbeds, you should not view that as a blocker to being able to join those testbeds. There's a lot of competitors that are on the same testbeds.
Anybody want to ask a question out there? I've still got more. You're going to have to put up with my questions if you don't ask any. Well, so I'd like to move in another direction again. So besides the testbed program, the IIC publishes white papers on innovation, on white papers on architecture, which have been mentioned a couple of times already, on white papers on security, security framework, and most recently, just about 3 weeks ago, a white paper on essentially a connectivity framework, cleverly called the Industrial Internet Connectivity Framework. Like everything we do, completely unpronounceable, ICF.
Marketing problem.
Yeah. So how do we, what's the relationship between all of these white papers, the architecture and connectivity and so forth, and the testbed program? It would seem that they ought to be related. Anybody want to address that?
Yeah, so I mean, part of the approval process is you have to go through a review of each of the frameworks with the architecture committee, with the security committee, and now with connectivity, so that you are at least know what they are and be knowledgeable about that. And we're actually putting in place a process where we're going to review it regularly in the future as well. Very much trying to both learn from the test beds and push the technologies down to the test bed. One thing I should have picked up with the test beds before, you know, they aren't technology demonstrations. If you're going to come in, you're going to have a 6-month schedule and you're done at the end, you're going to ship the product. That's not a test bed. You've got to learn something. Failure is just as good a result as success, because then we've learned something about that. And one of the things we want to learn is that connectivity framework really good? Can you use the architectures in the reference architecture for all the test beds? The new version of the reference architecture has some new architectural patterns in it because the architectural patterns that were in there did not cover all the use cases we wanted to do. So we're definitely learning both ways. It's an iterative process, and it's a very powerful process.
So you'd say all of the test beds are fully aligned with those white papers?
No.
I'll let somebody else answer that.
I would say something a little bit different. On the one hand, you need to refer to the architecture framework documents when applying for a test bed, but you find that when you're actually implementing your test bed, you need an architecture. We're dealing with advanced technology, some of it not yet tried. We're doing ambitious things with lots of different players at different levels in the architecture, and so you need an architecture in your own interest to come up with a good solution.
No, I'd absolutely second that. Not all elements of the IIRA is applicable to every solution or test bed. So I think elements that make sense are applied. The level at which each of these capabilities is applied is also different. But yeah, it's a very interesting way to make sure that the architecture also evolves along with the evolution of the test bed.
No, Stan actually made the point that the results of the test beds actually have had impact on the architecture document, and the architecture framework has actually changed. Do you see that happening to the security framework, to the innovation framework, et cetera?
At least for the innovation framework, yes. Security framework, I think we're all learning as we go.
It can't be changed.
Yeah.
Secure.
I think it's not just about risk mitigation, but new technologies, new capabilities, new processes, new types of skills. We're getting to know it every day. I think every day is a different level of maturity for all of us. So as time progresses, I think the framework and the architectural documents need to evolve as well. They're not static, it's a live model.
Yeah, and I actually think that's a strength of the IIC process. It's not a linear waterfall kind of process where we take standards, we build an architectural document, and then we prove it out in test beds. That's also not how the world works. And so it is messy. And so we are being much more fluid, where we've got experimentation and learning and failing that's happening in parallel, really in all of these different facets. And again, I think for the members, for the 260 now members of IIC, I think that's a pretty good sign that it works well, and that's really what we're looking for, is not to be dictated of here's the solution, but to have a place where everyone can kind of in this messy environment contribute, and then we vet it out as we move forward.
So Todd, you talked about standards input into the test beds. I'm talking about the other end, which is how we learn from the test beds and then share that information with standards organizations. Nobody wants to address that, really?
Well, are you looking for examples, or are you looking for agreement?
Examples are fine, but how would you like to see that?
Well, so we have liaisons already in place with a number of the standards bodies, IEEE, AVNU, OPC Foundation. So we have liaisons. We already have processes, both formal and informal, where I think that communication is going back and forth. I'm not sure that it's necessarily broken right now. Like anything else, there's always ways to make it better, but it is a well-connected community. And that happens both, again, through liaisons and then through a lot of individual people that put in the time and energy to make those connections on a personal level.
So by now you want to join a test bed, all of you. Or you're asleep. You might be asleep. Do you have any questions about how to join a test bed, how to participate in a test bed? You just want to see us sweat, basically. Why don't you give an example? Yes.
So I'll give an example of a standard that is at least heavily influenced by a test bed. In the power control world, there's something called OpenFMB, which stands for Open Field Message Bus, which is actually Duke doesn't like calling it a microgrid architecture, but it's a locally controlled electric grid architecture. So if you go, to your house or your business today, there's no computing on the power poles outside of your house today. It's all, there might be fancy. You might be able to what's called behind the meter in the house might have something if you're very advanced, but most of the control today is at a central office. Maybe there's a little bit intelligent in the substation, but there's really no neighborhood level control, and it's very difficult to take the very fast changing renewable energy sources like wind and solar and integrate that into the grid. And the microgrid testbed, and I can't say it was the only influence on this, but certainly is an active testing of the design of this thing called OpenFMB. And what's come out of that is a much better understanding, a data model, which is really the types of data and the rates of data and the reliability of data required for that. And it got to be sufficiently sophisticated that we took it to the NASB, North American Energy Standards Board, and actually got a standard approved in about a year after we took it there, which is blazingly fast for that industry. It's typically 5 to 10 years, and part of that is because we had a lot of different organizations involved in the test bed. We had a lot of different, real tests going on. Some of them sort of the traditional pilots at real utilities, but other ones in innovative companies like National Instruments Lab that we could take and point to how it actually worked. And that standard's going to have to evolve. I'm sure I can promise you right now it's not implementable today, but it isn't. Most standards in their first form are not implementable. I've got a standards expert here that will back that up, or at least not useful.
Or make no comment.
But it will be, and it's definitely a big step along in the right direction so you can start building things. Right?
So let's switch gears a little bit again. And we've talked about outputs of the test beds, which are good for the industry. We've talked about outputs of the test beds that are good for standards organizations. How about outputs that are good for your company? I mean, what are you trying to get out of participation in test beds? What's Fraunhofer trying to get?
Right. The main benefit for us is to establish a network of cooperating organizations who are interested in joining our testbed or participating with us in some way in the testbed. That is spin-off projects, because we don't sell technology as such, as in the form of devices. We sell solutions and research projects. So for this point of view, the testbed is excellent. The other aim that we have is to advance certain standards. We are very active with 2 standards, OPC UA and Automation ML, and we hope to use the testbed as a vehicle to show how these standards can be used in a positive way and promote their use in other testbeds or in other applications.
So that's a research organization. How about a company that's trying to sell product?
So if I asked you today what's holding back the industrial Internet of Things, what's the blocker? Remember, I like blockers and mitigation strategies. What's the blocker holding it back? I mean, there's several of them, but if you actually ask people, most people will say there aren't well-defined standards for interoperability, and security is the other one. Those are the 2 big answers everybody gives you.
And not in that order.
So if you want to be a small company that's growing aggressively and finding a market, one of the things you better get out of your way is that standards blocker. So the test beds allow us to show our customers, here's not just us, but us and National Instruments and Cisco and all these utilities or whatever that are all saying, this is a way to go build this system. And even if they aren't willing to go out and build an entire grid with it, that's a big investment, they are willing to go out and build other test beds. We have Oak Ridge National Labs building a test bed compliant with OpenFMB. We have NIST building one. San Diego Gas and Electric just put out a request for proposals to go build something compliant with it because they see that being built somewhere else. So get rid of the real blocker, in my humble opinion, is confusion. There's a ton of confusion in this market. Nobody knows, should I pick OPC UA? Should I pick DDS? Should I build it this way? Should I use this standard? And the test beds give you a very clear, here's what we did, here's what didn't work, don't do that, you idiot. Here's what did work, at least that's a good shot. And that's hugely valuable in the industry.
So it sounds to me like a go-to-market strategy. Todd, you want to, is that right?
Yeah, I think for us it's ecosystem and it's marketing. So we need ecosystem because we don't make every piece that our customer is going to need to solve these IIC systems. So we need other products to solve that. And then once we together have a working system, we need help marketing that so that the customers can understand if they put these pieces together in this way, it's going to meet their problem. So those are the 2 reasons business reasons we join.
Does that sound right?
Absolutely. In fact, the co-innovation with multiple partners is very seamless with these test beds. The reason is because if you look at the edge, the platform, and the enterprise tier of any IoT solution, everybody comes in, and when they join a test bed, it is just a matter of getting a TPA in place so that they become a member. It is not a very convoluted one-on-one NDA discussion between partners.
It's a testbed promotion agreement.
Yes, the testbed promotion agreement, the TPA. So I think it enables an accelerated way of bringing partners together and co-innovating together, even if they compete. For example, at the edge tier, you may find several ARM technologies, you may find several Intel IA technologies. It's a very cooperative environment, but IIC and the testbed program actually facilitates that. So the second pillar is around go-to-market. See, we are a systems integrator, so we tend to work with thousands of customers and clients with real use cases, real-world use cases. So when we have to actually deploy them, it is very easy for us to try out a combination of the edge platform and enterprise tier in a testbed scenario. For example, if we take a predictive maintenance solution for a manufacturing customer, in that case, I can work with the Microsoft Azure IoT stack at the back end. I can work with the IBM Watson stack. I can work with PTC ThingWorx stack. I can work with GE Predict stack. Literally all of these members, these great companies producing great products, are part of the IIC. So I don't have to go anywhere outside to strike one-on-one deals. It facilitates multi-partner, multi-use case, multi-domain kind of solutions. We can put those things together. In fact, it was mentioned earlier about interoperability between something to something is a very important factor here. I think with IIC Testbeds, we are able to do interoperability even between domains. Sometimes we build a manufacturing solution, but the same sets of technologies solve a problem in the utilities and in the energy and in the precision agricultural sector. So it is sector agnostic.
Can we talk about one of those? Can we something that crosses vertical lines? Anyone? It doesn't. Well, it sounds like a really good idea. But
OK. It comes back to me. So in terms of something that crosses sector, if you look at the edge tier, and you have to acquire some real-time data, high volumes of data, a solution around edge analytics for a manufacturing customer, or a medical device equipment manufacturing customer, or let me take an example of a transportation fleet management solution customer. In all of these cases, the underlying methods and ways of collecting and ingesting the data, conducting the analytics, storing and visualizing the analytics, and the insights and outcomes, you could literally do it the same way. It's just the payload is different. Maybe the frequency is different on how the payload comes in. The data models are different. The asset models are different. But the same solution in a different way could be applied to different sectors. So use cases may vary. The reference architecture may be a constant.
I know Stan's got an answer, too.
Yeah, so there's really sort of two types of test beds in the IIC. There's vertically focused ones like microgrid and connected healthcare and crop management. But there's also horizontal ones. And if you want an example, just look at that board right there. You can see it. It says Industrial Internet Security Framework in Action. That's the security test bed. It's got a mix of huge companies like UL and Intel and Bosch and Siemens, and smaller companies like Wipro and ACAS and RTI and Tripwire. I mean, that is a great example. That's a horizontal test bed. Security is valuable everywhere. We are really putting together a way to test security in an industrial environment that can be used across industries. So, RTI is involved in 10 different industries with a very narrow value, a very wide industrial footprint, very narrow value proposition. I think that is a very common use case, actually.
So security problem is solved, and we got that great board over there.
No, but the security problem is being tested.
OK.
And we're going to learn stuff from it.
That gives us another opportunity to ask questions, if there are any.
He's got a question.
Who's that?
Guy here in front.
No? You're trying to make him ask a question.
I'm implanting a question.
So what I keep hearing about is all these different test beds. Why are there so many test beds?
Oh, I know.
So why? I think it's 27 at the moment. We really need so many test beds? We're not even in 27 vertical markets.
We need more test beds. First of all, I have no problem with competing test beds. Just because Schneider has a test bed doesn't mean Siemens can't have the same kind of test bed in a competing market. That's fine, because we're going to learn something from it, and everybody takes a slightly different direction. But I think the test beds, if anything, the space for the industrial Internet of Things is unbelievably huge. I don't know if you've seen the vertical taxonomy we put together. I'm going to talk about that in my talk on Thursday, but it's amazingly huge. There's so many different applications, so many different directions. And eventually, I'm a big fan of the word internet and Internet of Things. Most people are just, an Internet of Things, especially in the consumer market, is my watch talking to a single or my health Fitbit talking to a single server in the cloud, and that's the Internet of Things. And well, it is putting a thing on the Internet. That's not the same as the Internet of Things. The Internet of Things is a new, especially the industrial Internet of Things, a new infrastructure for the way the planet works. And that's complicated. It's different in every industry. If you're going to build an architecture that's going to work for that, you better test it in more than one venue, and more than one architecture, and more than one set of companies, and more than one vertical to make that even start to be a claim. We want to lead that market. We better be in that market, and that market is a lot of different areas.
So just to amplify that, even in one area, the Bosch Tech Mahindra testbed was started in Hamburg in southwestern Germany,
right,
but is now being track and trace, but now being rolled out to all 250 Bosch manufacturing sites worldwide.
Right.
National Instruments is now in that testbed as well, as is Cisco, I believe. So that's a great example where learning, even from in one vertical market, even with one testbed program, can be rolled out on a worldwide basis, and you can learn more about how to apply that technology, how that use case is affected by rolling it out in so many different places at once.
Yeah.
So I think Todd wants to.
Yeah, I'll comment one more. You were asking about, is there a need for 27 or more test beds in the future? And I think an important attribute of these test beds is that they can, and in my opinion, some of the most valuable ones are very vertically focused. Because when you can get very vertically focused, very specific on a problem that you're trying to solve, that's, I think, where you start to end up with a much greater value to the end customer. Because the problem that end customer is facing, we, now the collective entities that really understand the technology and the products, have really focused together on solving that problem. And I think that's a value in these vertical test beds that can't be understated. So yes, I think as long as there are point applications that are of market value to solve, a test bed is a phenomenal tool to solve those.
Well, no, so Sten, you said that you want a lot more test beds. Are we going to see some more this year?
Well, to answer your original question, why are there so many test beds? I think there are two aspects. One is that there are lots of different sectors, and people are coming up with more really great ideas on how to merge sectors together to provide a solution that has aspects of both sectors. For example, manufacturing and energy management in the manufacturing process, or smart cities. We have lots of different things coming together. And then there's another very simple reason for why there's quite a number of test beds, and that I think it's fun to have a test bed and gather all this experience.
Yeah, it's really just about fun. Yeah, go ahead.
Yeah, talking about fun, I think we are just getting ramped up to add another few to the test bed list. So there are many use cases.
Give us a hint. What do the use cases look like?
So I think your classical asset management use cases are very popular. All kinds of different assets out there. In the manufacturing industrial sector, the supply chain, connected supply chain solutioning, that is actually a fast evolving space. In terms of the fleet management, transportation solutions, I think more and more technologies like machine learning, technologies like AI, technologies like distributed edge analytics, we haven't really tried out the application of those in certain use cases like these. So I intend to bring in a lot more new ideas so we can fail fast and succeed fast. I had to qualify the second term because you just don't say fail fast and just leave it at that, right? I think the point is there are many use cases. If you look at the variability of use cases by sector and by industries, the Internet of Things, the technologies on compute, storage, and networking is evolving so fast. I think it's enabling new service models, product as a service. If I look at it, just by looking at this last month, we did 4 solutioning around products as a service, welding as a service, fragrance as a service. I mean, literally the ability of a connected device to enable a new service offering has taken off. Now, what does that mean in terms of test beds? There are many ideas that we want to try them out with multiple partners and fail fast and succeed fast.
Okay, fair enough. Yep.
Actually, we're working on an oil and gas test bed, which there isn't one in the IIC so far. I mean, an entire huge industry that doesn't even have a single test bed. I mean, there's many, many, many test beds out there. And you know, if you actually look at the IOSC, there's what, 270 plus companies. There's only 27 test beds. That's only 1 for 10 companies. And we're in 5 of them. I mean, there's a lot of room for more test beds. And actually, one of the things that he picked up on, it, people do it for marketing to some extent. I've actually heard a criticism of the IOSC as a marketing organization at some point. My business school education definition of marketing is the effort to change the way people think. If that's how you define marketing, I love the characterization of the IOSC as marketing. That's what we're doing. We're changing the way people think about how to build these systems, about how to work together as companies, about what an internet is, about what the industrial internet is, and about how to get guidance from a consortium to actually go out and build these systems. That's what we do. Test beds are a big chunk of that. Not all of it, but a very definite chunk of it.
So it's bad and it's good.
What's
marketing?
Marketing's good. I actually proposed that we 10x the budget to marketing in the last steering committee meeting. Which made her a fan. As our marketing director here, by the way.
I want to ask one more question about test beds, and then I think we're pretty much done because I think we've put them to sleep. And that is this booth is about the cooperation between the Industrial Internet Consortium and Platform Industrie 4.0, the German program of the German government to increase economic success in Germany through the use of IoT in manufacturing and production. So that's why you see on the list there both the Industrial Internet Consortium and Platform Industrie 4.0, and as well as VDMA and ZVEI, two German organizations. So the question is, if they've got a testbed program and they claim 200 testbeds, although I think that's what we call we call use cases, not testbeds, and we have a testbed program, shouldn't there be something joint? So. Somebody want to talk about that? Yeah, Kim wants to talk about that.
Right, certainly we think there should be something joint, and as I mentioned at the beginning, we have a couple of model factories in the I4.0 labs network, and we have our IAC testbed as well, and so there's a good opportunity to have something joint. Both initiatives can learn from each other, and here in Germany in particular, there's an enormous demand at the moment for general advice. What are these two initiatives all about? What are the differences? What are the commonalities? What does a smaller company have to do to become familiar with the technologies? What happens if you choose one and not the other? And there are lots of open questions there where good advice is necessary.
Fair enough. Jayraj, did you want to?
I'll just add to it. It is imperative that both of these bodies, the Industry 4.0 and IIC, collaborate, not just at the architecture level, not just at the use case level, but also in terms of estimating and articulating business value to the customers. Because this digital transformation journey is not unique to one part of the world. It's a global phenomenon. So I think the more road shows you do between these two consortia, I mean Industrial Internet Consortium and I4.0, it'll only help articulate the value proposition to the clientele worldwide.
Anybody else?
I mean, there is a very active program effort to put together Industry 4.0 and IIC technology and test beds and architectures and everything like that. I don't think they overlap as much as people think. You know, as I said before, Industry 4.0 is about making things, and IIC is about making things work. And there's just not that much there's very little direct competitive overlap. But you know, in that overlap space, there's absolutely a lot of work going on to make that happen. I don't know.
Okay. One more chance to ask a question. Yes, ma'am. Can we get a microphone over there? We have a... Yeah, here we go. It's coming. Can I take that one?
So with this test bed, can you say what is the biggest impact you have achieved through this test bed experience? So concrete. For example, ecosystem, quality, whatever. So to show an example, what impact you have achieved?
So I can name one that actually I'll talk a little bit about track and trace, which I suspect Todd can as well. But one of our oldest test beds, I think it was our second announced test bed, or first announced, but actually second started, was track and trace test bed. At first it was Tech Mahindra and Bosch, and in a single Bosch factory here in Germany. Now National Instruments is participating and Cisco is also participating. And although that test bed is still running, and they've changed the terms and actually changed some of the things that they're looking at over the last 2 years since it was announced. The results have been so positive in terms of more efficient use of the factory floor and safety of the factory floor that they're already rolling it out to 250 Bosch manufacturing plants, as well as some major Bosch customers in Europe. So that's a pretty simple metric. It's already made money for them. Anybody else want to talk about other?
I mean, I'll comment on the TSN test bed that we started about a year and a half ago. And like I said, as I look at the value of test beds, and this test bed was recently voted the most impactful test bed for IIC. And I think part of the reason for that, when we started, it was about 5 companies that were working on different pieces of this new technology stack and agreed we need these to all work together to really deliver on the promise. And the number of plug fests, I think we've ended up with 6 different plug fests. We've had it on multiple continents now. We actually have 2 instances of that test bed, and it's served really as a focal point for the industrial community who's trying to implement this new technology to bring their pieces in and understand how it's all going to fit together. So I think serving as that kind of lightning rod focal point for folks that are trying to invest, that's been a big success that would have been very difficult to do without IIC and the testbed program.
Any other questions? Yes, sir.
My question is related to oil and gas process industry. So what do you think when this technology can be employed in oil and gas process industry?
So speaking as someone who's going to keynote a downstream oil and gas event in September, I hope the answer is really soon. But as Stan actually mentioned that they're working on an oil and gas project now, I can talk about some things that are being done in Australia, but maybe you can talk about something that will be coming through IIC.
Maybe I'll start with one of my favorite IoT stories. So, you know, ExxonMobil started an organization that's now called OPAF, Open Process Automation Foundations or Framework, something like that, that actually Exxon hired an aerospace company, Lockheed, or a defense company, Lockheed, to build an architecture for downstream oil and gas based on, originally anyway, based on an architecture done for avionics. I mean, that is a classic cross-industry, you know, cross-fertilization result. And it's not a test bed result. You might think that while we're doing a test bed, maybe it has something to do with that. But that is, you know, but there is no oil and gas test bed at IIC yet. We are working on one. If you want to talk about it, and have you talk about it. But you know, the opportunity in that industry, as in almost all industries, to learn from other industries and bring some technology in they don't have today is really what the industrial thing is all about. It really is a convergence. Not just, you hear IT and OT all the time, but it's not just IT and OT. You can take an oil and gas oil refinery and build it based on an architecture done for avionics. You can learn about how to build a medical CT scanner by looking how robotics are put together. You can, I mean, the opportunity for cross-fertilization has never been anything close to this. And the IIC actually, I would argue, created the Industrial Internet of Things market. You know, Stanford Business School definition of market is a group of consumers with similar needs who communicate. I mean, our customer set and many others have good argument. There are consumers with similar needs, but there was nowhere to communicate 3.5 years ago. You couldn't go anywhere and talk about how an automotive system worked and how a manufacturing system worked and how, you know, hospital systems worked in any one place where you could communicate. You had to go to 12 different trade shows or something. Now there's a place where you can go and see the commonality. You can talk to people that have had experience in all these different things and put together an architecture that's much more powerful. If you actually look at the technologies that have impacted the planet and changed things the most, they are in multiple industries. Ethernet. I got Linux on my cell phone. You know, Wi-Fi. All of these things came from one place, but soon became useful in many places. And when they're useful in many places, they get cheaper, they get better, they can do things you'd never think. I mean, I wrote a paper years ago how you might be able to use Ethernet in a factory someday and all about collisions and deterministic. Now we've got TSN, you know, switching hubs got rid of a lot of the collisions, but they're still not. Now it's really getting where you can take that same kind of technology and put it into real manufacturing systems with real hardcore deterministic requirements. That's hugely transformative, and not just for one industry.
So I was going to let Stan have the last word because we've run out of time, but I will answer the gentleman's question
RTI,
directly.
go buy our stuff.
I will answer the gentleman's question, which is when will it be applicable to oil and gas? And I think the bottom line answer is now. So thank you very much for attending. Thank you to the panel for making it a useful panel. And I hope that you enjoy the rest of the forum, which goes all the way through Friday. And I'll hand it back to Tobias. Thank you.